Let us solve some trigonometric integral problems. But first, for simplification, let us write down the derivative table for trigonometry. So the derivative of sine of x would be equal to cosine of x. The derivative of cosine of x would be equal to negative sine of x. The derivative of tangent of x would be equal to secant squared of x. Derivative of cotangent of x would be equal to negative cosecant squared of x. Derivative of secant of x would be equal to secant of x tangent of x. And the derivative of cosecant of x would be equal to negative cosecant of x cotangent of x. Now that we have this table, it will be much more simpler to solve it. So let us start with our first problem. The integral of 3 sine of x minus 1/2 cosine of x dx. Now let us split this integral into two parts. So this would be equal to the integral of 3 sine of x dx. The operator here is a negative, so this would be minus integral of 1/2 cosine of x dx. The next step would be to put all constant outside the integral, such as all this number. So this would be 3 integral of sine x dx minus 1/2 the integral of cosine of x dx. Now, let us now focus on here the integral of sine of x and the integral of cosine of x. We see here earlier that this is the derivative of these trigonometric functions. And so, know that the derivative is the opposite of an integral. So, by that logic, the integral of cosine of x would be equal to sine of x. And so, by this table, we can deduce or we can identify what the integral of each of these are. So, first up, the integral of sine of x. So, in our case, sine of x here would be equal to cosine of x. But since in our table, it is negative sine of x, so this would be negative cosine of x minus 1/2 multiplied by the integral of cosine of x. Next up, cosine of x. The integral of cosine of x would be equal to sine of x dx. Wait, not dx, I mean plus c. So simplifying this, our final answer right here, this would be equal to negative 3 cosine of x minus 1/2 sine of x plus c. Next up would be the integral of 2 secant x multiplied by tangent of x plus 5 cosecant squared of x all dx. So, first up, split the integral into two parts. So, this would be like this. And the next step would be to put the constants outside the integral. And so, let us focus on this. First up would be the integral of secant x tangent of x. So, this would be 2 multiplied by the integral of this, which is this one, secant x tan x So the integral of secant x tangent of x would be equal to secant of x plus 5 multiplied by the integral of the second part, which is cosecant squared of x. So it would be this, and the integral of this would be equal to cotangent of x. But since in our table it is equal to negative cosecant squared, so this would be equal to negative cotangent of x plus c. And so the final answer right here would be equal to 2 multiplied by secant x minus 5 cotangent of x plus c. The integral of tangent squared of x plus cotangent squared of x plus 4 dx. So if you can see here, we have a tangent squared and cotangent squared. But when we see on this table, there are no cotangent squared or tangent squared. So that brings us to finding its trigonometric identity. Know here that tangent squared of x plus 1 is equal to secant squared of x. And cotangent squared of x plus 1 is equal to cosecant squared of x. So by transposing the one to the other side, we would have the value of tangent squared of x would be equal to secant squared of x minus 1, and cotangent squared of x would be equal to cosecant squared of x minus 1. So let us rewrite this first. So this would be the integral of tangent squared of x here would be equal to secant squared of x minus 1 plus the value of cotangent squared of x, which is cosecant squared of x minus 1 plus 4 of dx. So simplify this. This would be secant squared of x minus 1 plus cosecant squared of x minus 1 plus 4 of dx. 4 minus 1 would be equal to 2. So you are left with the integral of secant squared of x plus cosecant squared of x plus 2 of dx. Now you can see here that secant squared of x and cosecant squared of x does exist in the table. So we can split this integral into 3 parts. Since 2 is a constant, we can actually put it outside. And so focus on the first part, the integral of secant squared of x dx. So the integral of secant squared x would be equal to tangent of x plus the integral of cosecant squared of x. So it would be this. Its integral would be cotangent of x. But since this is negative cosecant squared of x and ours is positive, just flip the sign, which would be equal to negative cotangent of x plus 2 multiplied by the integral of dx is simply x plus c. Thus the final answer would be tangent of x minus cotangent of x plus 2x plus c. The integral of 4 cosecant x cotangent of x plus 2 secant squared of x dx. So we can see here that cosecant x cotangent of x exists and secant squared of x also exists. So no need to do something like this. This only applies to tangent squared and cotangent squared of x. And so split this integral into two parts. And so we can actually automatically move the constant outside the integral. So this would be 4 integral of cosecant x cotangent of x dx plus 2 integral of secant squared of x dx. So focus on this, the integral of cosecant x cotangent of x. The integral of this would be equal to cosecant x. But since ours is a negative, this would be negative cosecant x plus 2 multiplied by the integral of secant squared of x. It is equal to tangent of x plus c. And so the final answer would be equal to negative 4 cosecant x plus 2 tangent of x plus c. The integral of 2 cotangent x minus 3 sine squared x all over sine of x dx. So first thing you're going to do here is to simplify this. So split this integral into two equal parts with the denominator as sine of x because they both share the same denominator anyway. So this would be the integral of 2. We can actually put 2 outside now, the integral. 2 integral of cotangent of x over sine of x minus 3 sine squared x, so put 3 outside, sine squared of x over sine of x. Wait, this should be multiplied by dx. So if you try to simplify cotangent into its simpler formula, which is equal to cotangent would be equal to cosine over sine. So cotangent over sine, this is equal to cosine over sine squared. You will not be able to gain anything here unless you will use u substitution. But for this, there is a much simpler way. Just move sine to the top. So this should be 2 integral of cotangent multiplied by sine, or the inverse of sine is equal to cosecant. Note that cosecant of x is equal to 1 over sine of x. So this should be equal to cotangent of x multiplied by cosecant x minus 3 integral of, so this will be divided, so you are left with sine x here dx. And so focus on the first part, the integral of cotangent x cosecant x, which is this. It is basically the same. It does not matter whether the cosecant is at the first or at the last. So cosecant x cotangent of x is the same as this anyway. So the integral of this would be equal to cosecant x. But since it is a negative, this would be equal to negative cosecant x minus 3 multiplied by the integral of sine of x, which is cosine of x. But since this is negative sine of x, which corresponds to positive cosine of x, if sine of x is positive, it is obvious that cosine would be negative. So this would be negative cosine of x. And so the final answer would be equal to negative 2 cosecant x plus 3 cosine of x plus c. Let us try some different problems now using a technique called u substitution. So let's start first with this, the integral of cosine for x dx. So you might think that you will just use this table, but no, you shall see here that we have a 4x, but in this table we only need an x. So it is only a single variable, not something like 4x. So what we're going to do here is to use a technique called u substitution. So let u here be 4x and take the derivative. So du would be equal to, the derivative of 4x would be equal to 4, and multiply this by dx. And since we need the value of dx, transpose 4 to the other side, so this would be du over 4. So substituting the value, we would have the integral of cosine of u multiplied by dx, which is equal to du over 4. So since this is a constant, we can actually put it outside. So this would be 1 over 4. Note that it is 1 over 4. Because in this case, it is du over 4. The integral of cosine of u multiplied by du. So if you can see here, it is actually similar, the cosine of x and cosine of u, but the only difference is the letters here. But that is actually okay, because whether it is sine of y or sine of u or any variable, as long as it is a singular, it corresponds to the same, which is cosine of y and cosine of u. So this is equal to 1/4 multiplied by the integral of cosine of u, which is equal to sine of u. U plus c. And so simplify this, this would be 1/4 sine of u plus c. And the last step would be to revert u back into its original form, which is equal to 4x. So the final answer would be equal to 1/4 sine of 4x plus c. The integral of 6x squared sine x cubed of dx. We can see here again that x cubed is not the same as x. So we must use u substitution in this. So let u here be x cubed. And so take the derivative, which would be equal to 3x squared, and multiply this by dx. And so isolating dx, this would be equal to du over 3x squared. So substituting the value, this would be 6x squared multiplied by sine of u. Dx right here would be equal to du over 3x squared. You can see here that 3x squared and 6x squared would be cancelled, leaving a 2 here. And so this would be equal to the integral of 2 sine of u du. And you can put 2 outside, so this would be 2 integral of sine u du. And so taking the integral of sine, it is equal to cosine. But since this is a positive and this is a negative. So this would be negative cosine of u plus c. Multiply this by 2. This would be negative 2 cosine of u plus c. And so the final answer would be to put u back into its original form, which is x cubed. Next up would be the integral of 2 sine x multiplied by the cube root of 1 plus cosine x dx. So, first up, you can see here that x here is the same as this. So, no need to use u substitution. But a couple of use, including this one, would be to substitute a part of it, which is next up would be the integral of 2 sine x multiplied by the cube root of 1 plus cosine x. So you can see here that sine of x is normal because it can correspond to that. And so you can use u substitution also in like a complex form such as this. So we would want this to be substituted to u because it is in a cube root form. So let u here be 1 plus cosine of x. Take the derivative. The derivative of 1 is 0. The derivative of cosine of x is equal to negative sine of x. And multiply this by dx. So dx right here would be equal to du over negative sine of x. Substituting this would be the integral of 2 sine x multiplied by the cube root of u multiplied by dx, which is equal to du over negative sine of x. You can actually see here that sine of x would cancel. You are left with the negative. You can put that outside the integral. At the same time, you can put this number 2 outside the integral. So this would be negative 2 integral of cube root of u du. Next step, when dealing with integral, make sure that all forms are in their exponential form. You must be aware that the square root of x is equal to x to the power of 1/2. That is because whenever a square root, this is automatically have a 2 there. But in our case, it is 3, so this is called cube root. So this would be equal to the power of 1/3. So by that, this would be negative 2 integral of u to the power of 1/3 of du. So, taking the integral of u to the power of 1/3, this is just power rule, so this would be u to the power of 1/3 plus 1 over 1/3 plus 1 plus c. This would be u to the power of 4 over 3 over 4/3 plus c. You can put 4/3 to the numerator, but it will reciprocate, leaving you with 3/4 multiplied by negative 2 u to the power of 4/3 plus c. 3/4 multiplied by negative 2 would be negative 6 over 4, or this would be 3/2 of u to the power of 4/3. And so, putting u back into its original form, our final answer would be negative 3 over 2 of 1 plus cosine of x to the power of 4/3 plus c. the integral of cosine cube 2x multiplied by sine 2x dx. So you can see here, it is a 2x. So first, try doing u substitution on 2x. Basically, using u substitution is like a trial and error. If you don't see the whole integral being simplified, that means it is not that. So let's try u equal to x first. So du right here would be integral of 2x, which is 2, multiplied by dx. So dx right here would be equal to du over 2. So try substituting that. This would be the integral of cosine cube of u multiplied by sine of u. Dx right here would be equal to du over 2. So you can see here, it is not simplified because it is not cancelled by anything. So you are left with 1/2 integral of cosine cube of u sine of u du. It is like complicated to take the integral of this. So what we're going to do here is to let u here be a different form. So it will not be 2x. Let's try cosine of 2x. Let's try this. So this should be cosine of 2x. So taking the derivative of cosine, let's start first with the outside. So the integral of cosine 2x would be equal to negative sine of 2x. And multiply this by the inner function, which is 2x. The derivative of that would be 2. And multiply this by dx. So du right here would be equal to negative 2 sine of 2x dx. So dx right here would be equal to du over negative 2 sine of 2x. So substituting that, this would be the integral of u to the power of 3. This is u to the power of 3 multiplied by sine of 2x. Multiply this by dx, which is du over negative 2 sine of 2x. So you can actually see here, we can cancel this. So this will be simplified. Negative 2, you can put it outside the integral. And so you can see here now that the integral is simplified. So u equal cosine of 2x is the correct one. Basically, it's just a trial and error. You will get used to it soon. So putting negative 2 outside the integral, this would be negative 1 over 2 integral of u to the power of 3 of du. So the power rule for integral, this would be negative 1/2 multiplied by u to the power of 3 plus 1 over 3 plus 1 plus c. And so this would be negative 1/2 multiplied by u to the power of 4 over 4 plus c. This would be negative 1/8 u to the power of 4 plus c. And so putting u back into its original form, the final answer would be negative 1/8 cosine of 2x to the power of 4 plus c. For the last problem, for the integral of 4 sine x over 1 plus cosine of x to the power of 2 of dx. So you can actually substitute u here as 1 plus cosine of x. First, it is because it is on the denominator. It is not mainly because of that, but it can be a necessary reason. And also because it is bounded by a exponent. Signs that you can put u sub in there is is that whenever you see a square root, whether it is on the denominator side or bounded by an exponent such as to the power of 3 or something like that. But these are the three main causes, or three main that you can put u as. Whenever you have questions, you can just comment down below and I will try my best to answer it. So, taking the derivative of 1 is 0, derivative of cosine x is negative sine of x dx. So, dx right here would be equal to du over negative sine of x. So, this would be the integral of 4 sine x over u squared. And dx right here would be equal to du over negative sine of x. You can see here, sine of x would cancel. And so you can put the negative outside and also the 4 outside the integral. So this would be negative 4 integral of du over u squared. And so you can actually put u on the numerator, but by doing that, the sign would change. So this would be negative 4 integral of u to the power of negative 2. Because the sign will change, this is positive, so this would be changed to negative of du. And so, by the power rule, this would be u to the power of negative 2 plus 1 over negative 2 plus 1 plus c. So this would be negative 4 multiplied by u to the power of negative 1 over negative 1 plus c. So 4 multiplied by negative 1, this would be actually be positive 4 u to the power of negative 1. And so, whenever you have a negative exponent, you can put it down on the numerator. So this would be equal to 4 over u to the power of 1. Because since you will put it on the denominator, the sign will also change, just like what we did earlier. But it is not necessary to put to the power of 1 here, plus c. And so, the final answer here would be equal to 4 over u here is 1 plus cosine of x plus c.